So in this video we'll check out part C and D of 2008 number 4. It is a no calculator question, and we have this velocity graph that we're working with, and in part C here it says between 2 and 3 is the speed of the particle increasing or decreasing? Give a reason for your answer. Well, the easiest way to think about speed, in my opinion, would be to define speed to be the absolute value of velocity or the magnitude of velocity if you're dealing with vectors from physics. But in our class, when the motion's happening in a single dimension, just left and right on the x-axis, speed is going to be given by the absolute value of velocity. So on the interval from 2 to 3, so if we look at this velocity graph on the interval from t equals 2 to t equals 3, what's happening as we progress across this little piece of the velocity graph? Velocity is getting closer to 0. And if velocity is getting closer to 0, the absolute value of velocity would be decreasing. Therefore, the speed of the object is decreasing at any time between t equals 2 and t equals 3. So speed is definitely decreasing on this interval, and the reason why is because velocity is getting closer to 0 on the interval. If you check out a different interval, if you check out the interval from 5 to 6, now we're not asked to concern ourselves with that for this particular question, but if you look at the interval from 5 to 6, what's happening with your velocity graph as you progress across it here? Well, velocity is moving away from 0, therefore the absolute value of velocity is getting bigger, and speed would be increasing on an interval like that. But in part C, decreasing, done. We gave the explanation verbally. And then in part D, it says during what time intervals, if any, is the acceleration of the particle negative? Justify your answer. Well, we hopefully remember that velocity is going to have a first derivative that actually equals an acceleration function. Right? The derivative of velocity, or the second derivative of position, is what gets us an acceleration function. So if we're trying to figure out where the derivative of something is negative, and we're looking at a graph of the function, when is this v prime going to be negative? Well, anywhere where you have negatively sloped tangents. We were told in the problem statement that we have a horizontal tangent at 1 and a horizontal tangent at 4. If you look at tangent lines on this piece of the graph, all of those slopes are going to be negative. So we do have a negative acceleration on the interval from 0 to 1. We don't have a negative acceleration from 1 to 4 because all the tangent lines on this piece of the graph would be positively sloped. And then on the last piece of the graph from 4 onward to 6, we're back to negatively sloped tangent lines, right? That tangent line would have a negative slope. All the tangent lines would have a negative slope. So our acceleration is negative on the interval from 0 to 1 and on the interval from 4 to 6 because those are the intervals where we have a negative value for the derivative of the graph.